So continuing, the probability of y equals -2 as x varies. Look at our table. Y is -2 as x varies. It is this column here. It's this column here. Then y -1 as x is varying is this column here. And also y equals 0 is that column. So meaning that, look at y is -2. So we sum all those things. We have 4 plus 3, that is 7, plus 2, 9, plus 1, that is 10. So this is 10C. Then for the second column, that is 7C. This is 7C. For the third column, that is 6C. The third column, that is 6C. So I have 10 plus 7 plus 10C plus 7C plus 6C. Therefore, this is equal to 23C. This is 23C. This is 23C, and it is 23 out of 40 since the value of C is 1/40. Then for part D, part 4, that was the probability of x equals 1. Let me hope so. Now x is fixed. X equals 1. X is fixed as y is varied. I have explained that case. X is fixed. X equals 1. X equals 1 is here. Y is varied. So we are in this row. We are in that row. And therefore, summing all those values, we obtain 7C. Obtain 7C. Therefore, this is equal to 7C. 7C, which is 7/40. Then for part 5, what do we have for part 5? For part 5, we want the probability that the absolute difference is less or equal to 1. Absolute difference is less or equal to 1. Now that sounds a bit technical. So we want to determine the probability that the absolute difference is less or equal to 1. So recall that my x is -2, -1. X is taking on those values. Y similarly is taking on the same values. It's taking on the same values. So here we are interested in the difference. We are interested in the case where the absolute difference. What is the absolute difference? For example, get an x value -2 and in a y value -2. Subtract -2 minus -2. -2 minus -2, this is a 0. And the 0 is less or equal to 1. It is less than 1, in fact. So this qualifies. The case for probability of x equals -2, y equals -2 qualifies. Why? When I subtract those two values, I get a 0, which is less than 1. Then I also look at another case, x. Still we are on x -2. So x -2 minus y, which is -1. This gives the -1. This gives -1. But remember, we are considering the absolute difference. The absolute value of -1 is 1, and 1 is less or equal to 1. Therefore, that also satisfies. So plus probability of x equals -2, y equals -1. I continue. See, I'm still on -2. I'm still on -2. So x, I have x equals -2 minus 0. -2 minus 0, I get -2, and the absolute value of -2 is 2. So you see now that does not satisfy. Then I go to x -2 minus y, which is 1. This is -3. Absolute value of -3 is a 3, which does not satisfy. And finally, -2 minus 2 is -4. Absolute difference there is 4, which still doesn't satisfy. So -2 is done. So you do the same thing for another value of x. What is the next value of x? The next value of x is -1. So we have -1 and -1 minus -2. -1 minus -2, that gives a 1, which is less or equal to 1. So that satisfies. So we have plus probability of x equals -1, y equals -2. I want to believe that the next one also satisfies. Plus probability of x is -1, y is -1. Because when you subtract the 2, you get a 0, which also satisfies. Then -1 and a 0 also satisfies. Probability of x equals -1. Probability of x equals -1. Y is a 0. -1 and a 1 does not satisfy. -1 and a 2 does not satisfy. So -1 is done. Then I go to a 0. 0 and -2 does not satisfy. 0 and -1 satisfies. So I have probability of x equals 0. Probability of x equals 0. Probability of x equals 0. Y equals -1. That satisfies. Then plus x is 0, y is -1 satisfies. Then plus 0, 0, x is 0, y is 0 satisfies. Then plus 0, 1, probability of x equals 0, y is a 1, that satisfies. So for 0, that case is done. Then I go to 1. 1 and the -2. 1 and -2, when you subtract, it doesn't satisfy. Let me hope so. Yeah, because you get a 3, it doesn't satisfy. Then 1 and the -1 similarly does not satisfy. However, 1 and the 0 satisfies. 1 and the 0 satisfies, and the 1 and the 1 satisfies. Therefore, I think 1 and the 0 satisfies, 1 and the 1 satisfies, 1 and the 2 satisfy. So I have probability of x equals a 1, y is a 0, plus probability of x equals a 1, x equals a 1, y is also a 1, then plus probability of x equals a 1, y is a 2. Then plus x equals 1 is done. Then I go to x equals 2. X equals 2 and -2 does not satisfy. I want to believe so. 2 and -2, when you subtract, that doesn't satisfy. Then 2 and -1 does not satisfy. 2 and a 0 does not satisfy. 2 and a 1, 2 and a 1, that should satisfy. So probability plus probability x equals 2 and a 1. Then plus C, probability of X equals 2, Y is a 2. So those are the possibilities. Those are the possibilities which are available. Therefore, I sum all those cases. Sum all those cases. This is a bit, and I want to believe that there in your book you can easily see the table. So look at your table. -2 and -2 according to the table which I have here. -2, -2 according to my table. That is -2 and negative, X is -2, X is -2, Y is -2. That is 4C plus -2, X is -2, Y is -1. X is -2, Y is -1. That is 3C plus X is -1, Y is -2. X is -1, Y is -2. That is 3C plus X is -1, Y is -1. X is -1, Y is -1. -1, Y is -1. That is 2C. Plus X is -1, Y is 0. X is -1, Y is 0. That is a C. Then plus X is 0, Y is -1. X is 0, Y is -1. That is also a C. Then X is 0, Y is 0. X is 0, Y is 0. That is a 0. Plus X is 0, Y is a 1. X is 0, Y is a 1. X is 0, Y is a 1. That is a C. Plus X is 1, Y is a 0. X is 1, Y is a 0. X is 1, Y is a 0. Getting C. Then 1, 1, 2, C. 1, 2, 1, 2, 3C. 2, 1, 2, 1, 3C. 2, 2, 4C. So when you sum, what do you get? If we sum, we shall have 4 plus 3, that is 7, plus 3, 10, plus 2, 12, plus 1, 13, plus 1, 14, plus 1, 15, plus 1, 16, 18, 21, 24, 28. Therefore, this is equal to 28C. And this is the same as 28 over 40. So in our next session, so that should mark the end of discrete. In our next session, we are going to look at the joint continuous distribution. Continuous distribution. Yeah.